Good afternoon, everyone. I hope you've all had lunch. Okay, good. So I hope I don't put you to sleep. Uh, so let's get to the topic. I'm sure a lot of you are wondering. We are in the biggest AI conference, and why am I here talking about regression, which is so like we said, regression is 200 years old, right? More than 200 years old. Uh, but why do I still love it? And that's what I wanted to share. But before we get to that, how many of you love regression? That's roughly about 20%. So I'm guessing the other 80% are neutral. They don't really hate regression so much. Otherwise, you wouldn't be here. Uh, one simple answer that I have is, old does not necessarily mean obsolete. And we've heard things like old is gold, but new is platinum. That's correct. But what I feel is regression, especially today, is more relevant than it has ever been in the last 200 years. And why I say that is, if you think about it, originally regression was built for use to be used in social sciences, right? It was used to establish relations between input and output. Things like prediction, forecasting were never really use cases 40 years, 50 years ago, right? It was largely used for social sciences. But now we've realized we can actually use regression for prediction and forecasting. And if we really think about it, these two are really the core use cases in any industry, right? Prediction and forecasting probably covers the maximum number of use cases, and therefore I think it becomes regression becomes that much more relevant even in today's scenario. Okay, so like I said, even from a business perspective, it is very relevant because it can potentially solve 50 to 80% of all machine learning related use cases across any industry that you can think of. We heard a lot of use cases from insurance industry, or even if you talk about banking industry, right? Whether it is cross sell, whether it is risk assessment models, whether it is your pre-approved credit card and fraud detection models, propensity to lapse out and those kind of things. All of these can be solved through regression. If we think about retail, propensity to buy, pricing elasticity, what should I sell, what should I not sell, all of those models can also be solved through regression. And similarly across different functions also, right? Marketing, the biggest question always is marketing ROI, marketing mix models. The back end is all regression models, and they are really very powerful models. Okay, so this is from a business side, right? Why regression is still relevant, but why do I love it? See, there are a lot of other models also which can solve the same problems, right? Why specifically regression? So I think the most important factor for it is, it is explainable. Today there is a lot of talk about explainable AI. People don't really want to appreciate a lot of black box models, etc. And regression has that inherent benefit, right? By design, it is completely explainable. There are absolutely no hidden elements in any regression model. And what it also does, because it is explainable, it builds intuition, right? And especially when somebody is starting on the data science journey or a machine learning journey, I've gone through that journey because it's a little difficult to imagine what the machine is trying to do. How is it able to take a certain input, give an output, which is so accurate? And what regression does is it really builds intuition for you. You're able to, like I said in the next one, it helps me understand how the machine is processing the data. How is the machine thinking about the problem, and is it aligned with how I'm thinking about the problem? So I think these three are really the fundamental reasons why I like regression, and why I think it is very important for everyone to go through this journey. Okay, if I talk about certain other elements, it has a certain level of creativity, I feel. And why I say that is, unlike, let's say, a neural network kind of model where you can just take thousands of inputs, put everything in the model, and it gives you an output. There's no creative element here. In regression, you really have to apply some sort of a art also to the science, while the back end is all hardcore science. You still have to think about, okay, what transformations will I do, what transformations will work, and there's a certain level of involvement that is there. What that does is it adds a sense of ownership to the model. Whatever model you build, you sort of feel very confident that I have built the model because there is certain contribution that I have done, It's not only the algorithm, it's not only some package that I've used from a library and I've built the model, and it builds, that level of ownership. So, the way I see it is, it's almost like a Lego of the ML world, right? There are so many different moving parts in regression, and you can always fit it and mix and match it in a way that you like, and the way it does your job, right? So I think that also adds to the reasons why I love regression. Let's continue. Now, coming from the technology side, of late, we've started facing challenges. The data is becoming larger and larger every day. All the deep learning models, neural network models would typically require, GPUs of infra and so on. But advantage of regression, again, it's not compute heavy, right? The most simplest versions, you can just run it in an Excel itself. It doesn't really need anything else. Plus, it is very stable and robust. And again, this is coming from the fact that it was designed for social sciences. By design, it had to be very stable and robust. You cannot have, people's behavior or social science patterns changing over time, right? So regression models that I have come across or I have built, I've seen they are very stable. We do talk about data drift, we do talk about model drift, but what I've seen is if a regression model is built properly, it is able to live through a lot of that, and you can really build a model today and use it for 2-3 years, unless there is a drastic change like COVID that happens, right? There are instances where we've not had the need to change the models for 2, 3, 4 years at a stretch because the models are still very, very stable. And despite the simplicity, we might think that regression models are so simple, will it give the required results or not? But again, I have personally seen that they give pretty good and stable results despite the simplicity. You can just have 4 or 5 variables, but the results are very good. So basically, in a nutshell, whatever I've spoken about in the last 5 or 6 slides, I love regression because it does the job, right? As simple as that. So no fancy stuff, no wells and whistles. It just does what it is supposed to do. So if there's so much good thing about regression, if I love it so much, why I think that at least of late people have started, or at least not love regression, right? Well, hate is a little strong word here, but why do people don't love regression so much? And this is purely my perspective. I'm happy to hear your perspective at the end of this. So first thing first, right? It's not cool enough, right? Machine learning, data science, very cool field, very hot topic. Everyone wants to talk about it. Everyone wants to jump onto it. But do you come to machine learning to do regression models? It's not so cool, right? Why would I do regression if there is so much fancy stuff happening? Okay, so that is one. Second, no offense to all those who are from service providers industry here, but the reality is you cannot really attach a hefty price tag to it, right? You cannot go to a client and say, I'll build regression model, but I'll charge 1 crore for that. He will never give you the money. You will have to talk about neural networks, you will have to talk about deep learning, then you can even charge 2.5 crores, right? So that's the reality of it. And third one, and this is more of a, both personal and organizational challenge that I see, it almost feels like because regression is old, because regression is simple, if there is a problem statement that can be solved through regression, it's not challenging enough, right? Something which is very exciting and challenging should require a neural network, should require a deep learning model. If it is regression, maybe it is too simple. Going forward, this I think is very important. It's not very easy, and why I say that are basically 2 reasons, right? One, like I said, it's not a simple lift and shift. You cannot just throw data to a model and it will give you an output. It requires a lot of experimentation, requires a lot of creativity, and most importantly, it requires a in-depth understanding of statistics, right? So because this is fundamentally built on statistical concepts, to be able to interpret what the model is doing, just going with that assumption of okay, p-value 0.05 is good enough, doesn't really tell you what the model is doing. So that's why I think one of the main reasons why people want to stay away from regression is because it also needs a base in statistics. Plus, it needs a lot of experimentation and iterations that we spoke about. Okay. Next one, while we said I love it because it is explainable, people probably hate it because it is explainable, right? Again, there's nowhere to hide in a regression model. You've built something, it leaves the door open for anybody to question why this variable, why this coefficient, why is it this, why is it that. As opposed to you throw an XGBoost model to them, they have no idea what this is doing, right? So it does leave you, it might be too transparent at times, and that is the reason why maybe people want to stay away from it, because it does leave you vulnerable, right? So it has the advantages, but it can become its own disadvantages as well. So having talked about the good things, maybe not so good things about regression, why I think it is very important, and like I said in the beginning also, especially for someone who's starting new in this whole journey, is because it builds intuition, right? It's very easy to just download some Python packages, pick up the data, run the model, get an output, check accuracy and all of that. But I think to sustain in this field and to really appreciate the power of algorithms and data science and machine learning, it's important to build the intuition in terms of how the machines are able to do such a good job. How is it that machines are able to process so much data and find out patterns, find out interrelationship between different inputs, and give you an output which at least all data scientists would claim is not possible by a human being, right? So regression, I think, does help you in that journey. It builds that foundation, builds the intuition, and it is very foundational. Like I said, having foundation in statistics, having that whole rigor of understanding what analytics goes behind the algorithm is very important. And like I said, if you start with regression, you start building your own confidence in more advanced, more complex machine learning models, because what I have realized is, the fancy names, the bigger algorithms, etc., in some way, the way they operate, at the back end, at least the philosophy more or less remains the same. Okay. From a business perspective, from a career perspective, why it is important, like we said again in the beginning, it can solve a variety of problems across all industries. What it does is it makes you relevant for jobs across any industry, right? Your skill set essentially becomes industry agnostic, because regression works in every industry, works in every function, can solve probably the maximum number of use cases anywhere across, right? And I think it's proven its capability that it's here to stay. It's more than 200 years old. It is still probably the most used algorithm, maybe not the most talked about, but definitely the most used algorithm, and it is here to stay. And the reason is that it is based on first principles, right? Statistics is never going to change. The way regression is built on foundation is never going to change. We can keep innovating around it, but the foundation will remain the same. So in a nutshell, because a picture is worth 1,000 words, regression is important because before you try to attempt something as fancy as this, it's important to learn to do this before, right? So that's what I want to close with. Happy to take any questions.